Everybody, I got to admit, this particular problem fascinates me because there's hardly any structure. The claim is that if you have 7 randomly selected distinct integers, there's a pair of them with a sum or a difference that is a multiple of 10. Now, being a multiple of 10 is the same as being, if A minus B and A plus B are multiples of 10, you can also say that 10 is a divisor of the sum and the difference also. And that's sort of motivated this statement right here. Now notice here this does say a pair. It says a pair. So that certainly means 2 numbers, right? And so that's sort of motivates why we write down the A and the B here in terms of the division algorithm. If you divide A by 10, you get a remainder that's always going to be less than 10, and the same with B. Okay. Now, since this is about remainders, really, because, I mean, you only have a finite number of remainders, namely 0 through 10, and so we write them in set notation here. Notice we write them in a fashion where we have sums of 10. 9 plus 1 sums to 10, 2 plus 8 sums to 10. Now, in this particular case, there are 6 possible sets the way we've arranged this, okay? But there are 7 numbers, okay? There are 7 distinct integers, right? So that indicates that 2 of the images will have to land in one of these sets, and that's essentially called the pigeonhole principle. And in fact, these guys right here would be the pigeonholes. Let me get that written down here. The pigeonholes. Takes a lot more time to write it than to say it, but these are the pigeonholes. Y'all, I don't know historically how this got so popular, pigeonholes, but it's widespread and very prevalent in mathematical literature. So these would be the pigeonholes, but you see we have 7 pigeons. Okay, that's what makes this thing so simple, and it solves a lot of difficult problems actually. Okay, so these are pigeonholes. All right, don't they look like pigeonholes to you? All right, they're pigeonholes. There are 6 of them, but the fact is we have 7 images of f. Now this is a strange function here. The output is a set, and that's a little hard for me to get used to. When I didn't figure this out myself. I just saw the solution somewhere, thought I'd show you guys. But let f and n be the set in S. This is the set S that contains the remainder. Okay, so this is kind of odd here, but f at 23 is equal, literally it's equal to this set 3 comma 7, because when you divide 23 by 10 you get 3. Now 7 doesn't have anything to do with anything here, but that takes a little getting used to. The image of f is a set, but one of these sets is one of the pigeonholes, and we have 7 of these images, which is the thrust of the problem. Now in a similar fashion, f at this number right here would just be the set 5. Okay, we have a couple of singletons here. Okay, so that's really what this is all about, and more or less this is the formal way to say it. Okay, now case 1, if the remainders are the same, certainly when we subtract a from b, the remainders, if these 2 remainders, r sub 2 and r sub 1 are equal, and I've written it right here, then the difference is going to be a multiple of 10, right? So we've taken care of it. It's a sum or a difference is what we're trying to satisfy, right? So this is a big check right here, right? Check off on that. Now case 2 is slightly more involved, but not too difficult. What we have right here is if the remainders are distinct, we've already handled if the 2 images happen to land in the set 5 or the set 0, then we're done, because that's just a special case of case 1, right? So therefore they have to land, these 2 images of f have to land into sets where the sum is always equal to 10. So in other words, 1 plus 9 is 10, 2 plus 8 is 10. I said this earlier, 3 plus 7 is 10, 4 plus 6 is 10. And so what we get right here is this value right here is just equal to 10. Okay, and there's 4 cases, right? But in all 4 cases, that's going to add up to 10. The 2 remainders are going to add up to 10. This is 10. Okay, and so we're checked off right here, and that really completes the proof. We're done right now. Now, I would challenge you guys to try to pick a set of even 6 where this is satisfied. It's kind of hard even to get a set of 6, but the condition is for a set of 7. And just so I won't lengthen the video, you guys can do that if you want to. But anyway, I thought it was a fairly simple principle to apply to a fairly difficult problem at the outset. Hope you enjoyed.